Welcome and welcome back to my channel. Today we're talking about recommendation system. Have you ever wondered why a recommendation system, like one used by Netflix or Amazon, sometimes gets it completely wrong? You watch one rom-com and suddenly your entire feed is filled with love story, or you bought a gift for a friend, and now you're getting non-stop recommendation for something you will never ever buy for yourself. And also, have you heard of the crazy story about 74 years old grandpa received a recommendation of a pair of black tights? Or your fashionable brother-in-law get a recommendation of a false eyelashes? That's intimidating. Or any other crazy funny story? Please comment below. In this video, I will break down 4 common mistakes lots of recommendation engine have, or what I like to call the 4 deadly things of recommendation system. Let's dive in. You might be asking, what exactly a recommendation engine? Recommendation engine, also called a recommendation system or personalization system. Simply put, it's a system that rank and suggest offering based on a certain calculated rule. Essentially, it's a ranking system for the top rank offering to a specific customer or a group of customers. This offering can be anything, a product, a service, a person, or even a content suggestion. The system itself can be rule-based, SQL-driven, or powered by machine learning or AI. We will focus on AI-driven recommendation engine today. According to the industry report from McKinsey & Company, over 90% of the company rank personalization and recommendation engine as one of their top AI applications. Most of the time, recommendation engine works well, but when they fail, the mistake can be extreme and sometimes even hilarious. Let's explore why. The first thing, ignore what's constant and what's changed in customer behavior. The importance to bring the industry insight and customer perspective. Let me ask you a question. Would you recommend the fashion product the same way you recommend the grocery item to your friend? Why or why not? Let's think. When you give a recommendation about grocery, which character and what fact you will consider it for your friend would love to buy? The brand, the taste, the price preference, or the type of food? On the other hand, which element do you think when you give advice to your fashion shopping? The body shape, the season trendy color, or the specific TikTok style you just see it 3 days ago? The point is, for different type of product, the customer has different consideration point for decision. If we want to give a high quality recommendation, we need to guarantee the machine are able to learn those relevant pattern for the sample data, right? Often, the company feeds AI with historical purchase record as example for learning. For this type of data, do you think AI or recommendation engine were able to get all of the information? Unfortunately, not. Like all the other prediction model, recommendation engine designed to learn what is not changed or the mainstream from the sample data. Here is the deal. Prediction model can only predict what stay the same. They rely on the pattern that don't change, which is constant. In other words, when we use historical data as input for recommendation engine, we assume past behavior pattern will continue under the similar condition. Why that matter, you may ask? In grocery, habitual buying pattern relate to the brand loyalty, the product type. If you buy chips every week, chances are you will keep buying chips rather than sweets. A customer who often buy the candy is like to continually purchasing candy rather than switch to fruit. Makes sense, right? But fashion. If you still use historical purchasing, what that means, if you like a baggy jean last year, you will not choose a skinny jean this year, even though the skinny jean is a trend. Or the hottest color last year was burgundy, and you will still buy the same color in the spring. Sounds ridiculous, right? Now, you may understand why you normally enjoying your local grocery store's promotion suggestion, but get really mad with the recommendation from the online fashion retail. Interesting? This brings us to the first takeaway. When building a recommendation engine, we need to find out which aspect of customer behavior or preference are stable, which therefore predictable from the sample data. So if you use historical data, what you need to find is from history and in future, what is not changed. In fashion, stability isn't about a specific product category or product specification, but the deep motivation. Find out which data can actually represent a personal social belonging and self-expression may work. And let's move on to the mistake 2. The second thing, calculating without a clear purpose. When recommendations lack direction. Compared to other predictive models, building and deploying a recommendation engine often requires significantly higher cost, more human resource, and a longer development cycle. But the surprising reality, few companies actually see a meaningful return on investment from those systems compared to the traditional customer segment method. Why? More often, the company lack of a clear business objective, a single clear business objective. Here are $1,000,000 questions. Why are they recommend the product in the first place? Is the goal to drive more sales volume, encourage purchase of high volume product or new product, or promote item with highest profit margin? Even deeper question, people rarely ask. Do we actually aim to make easier for our customer to buy familiar product, or do we want to inspire them with new possibilities? Or should the focus be on increase customer satisfaction and engagement, or actually drive sales or maximize profitability? That is why sometimes there will be missing match of the recommendation to the customer expectation. If you're a data scientist and machine learning engineer in the field, or product owner of the recommendation engine, you're likely familiar with the foundation of the recommendation engine, which is a system that rank items based on calculated affinity scores and other scores. It's just a ranking system. Design such a system involves critical decision-making, including what features to include, what data to calculate, how to assign the weights to different scores, how to construct the ranking metric, and more importantly, what kind of business rule we need to put on top of different ranking. Without clear understanding of the recommendation purpose, engineer may rely on default assumption when designing the system. This disconnect for the recommendation with business goal or customer expectation often lead to misrecommendation, fail to achieve the design impact. This leads to our second takeaway, the importance of defining the goals in recommendation system. And you need to communicate this goal clearly to your engineer team. Before you teach your team start to building the machine learning solution, ensure they have the clear understanding of your priorities. For instance, are you looking to boost the sales of the new product? Or whether you want to increase the awareness of a product variety in your assortment, or you want to maximize the sales of the top seller. Do you want to simplify repeat purchasing for convenience matter, or you hope to get more cross-sell or upsell? By defining and communicating this goal, you will align your recommendation engine with your business strategy and create the value you expected. This leads us to the third thing. Ignore the unbalanced customer base. Imagine this scenario. 85% of your registered customers are female, while only 15% are male. If you rely solely on purchase history to generate recommendation for all the customers, what will happen? Since recommendation engines are often driven by the highest probability across the entire sample base, which means the system naturally prefers towards female preference. As a result, your male customer might find themselves recommend false items instead of results. Consider it another case. if 80% of your current customers are over 35, and the recommendation engine will generate the recommendation more tailored to this age group, but may be irrelevant for the younger generation. The conflict will happen when you expect the younger customer is your target group for your company's next growth. Here is the challenge. You have a really unbalanced customer base based on your classification of your segment, no matter its gender, its preference, or its age. The machine learning models are designed to identify and amplify the most common pattern in the dataset. While this works well for the majority, it often overlooks minority group. So make sure you have a mechanism in the system to take care of your minority group. To bridge this gap, it's critical to first understand the composition of your current customer base, whether or not it's balanced or unbalanced. The second, identify the discrepancy between your existing and ideal customer profile. Let's move to the fourth thing, misunderstanding the customer identifier in the database and the individual customer. You may ask, what does the customer identifier mean? It is the unique representative or identifier in the database to present a unique customer based on the definition of customer for a specific company. We normally call it customer ID. It's like a number for a specific customer, and when you aggregate each purchasing record or something like that, and you will use that. Have you ever considered that the person linked to a specific customer ID in your system might not always be the same individual? There are two examples. First, a loyalty card might be shared among the family members, which means multiple people contribute to the same purchase record, and you can't separate each of them. The second, a purchase could be intended to be a gift for someone else, not reflect the registered customer's personal preference. Then you have the chance to make a mistake to combine both preference to a specific recommendation. On the other side, it's also true. You may have same customer, but have different customer ID from your different data source system. For example, in your internal CRM system, you have one customer ID, but the same customer have another customer ID from Google Analytics. And it will be challenged how you actually can match the ID in CRM system to the Google Analytics. And often, the company doesn't only have two data sources, have multiple. The same customer without for each purchasing session for the web, they will represent under different customer ID. So which means different batch of the purchasing actually belong to the same customer, but due to they are not actually logged in, you can't actually understand those behavior belong to the same person. You may ask, why does it matter? This means the record linked to a specific customer ID not really represent the specific individual's preference. This creates a fundamental limitation in recommendation system based on historical purchase data. While this issue is difficult to solve technically, awareness is crucial. Understand the limitation of your data and adjust your strategy according to avoid misleading insights. Recognizing this flaw is the first step to improve your recommendation. Don't let hidden bias in your data lead you astray. Be informed and plan smarter. Let's recap. In today's video, we call out 4 big flaws often the recommendation engine has and offer you the suggestion how to overcome them. First, don't assume the past behavior always predicts the future, since the recommendation engine only predicts the constant, which means you need to find out in the sample dataset what is the change and not change part for your predicted. The second, you need to have a clear goal for your recommendation engine, and you need to let your engineering team understand the trade-off and the priority of this value structure. Third, be aware of your unbalanced base of your customer data. Take care of your minority team. Last but not least, Understand, in the database, there's another thing called customer ID. This may not actually align with a specific individual. So when you're doing the recommendation, please think more and take care of those facts. Recommendation systems are powerful, but they're not magic. If you want to build a great recommendation engine, achieving your business goal and welcomed by your customer, please be more closer to your customer. Try to dig deeper why they do what they do and think from their shoes what they really want. Instead, just collecting and calculating the shopping or browsing records, you have more deep insight to truly care about your customer. Please make your engineer team informed and make them interested in the business insights and industry common sense. You can't expect a programmer talking the language as a fashion designer, but you can make them aware when designing an algorithm. There's much more to take consideration rather than mathematics. If you find out this video helpful, hit like button and subscribe for more insights. Drop a comment below. Have you ever got complete weird recommendation? Let's talk about it. See you in the next one.